Welcome to today's webinar. The topic today is effective use of building model add-on. Yeah, that's the add-on for RFEM 6. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, technical content of the website, the German and English webinars, customer projects, and so on. I will be the moderator today, and I will answer your questions during the webinar. My colleague Richard Hase will be the presenter. He's responsible for the building model add-on and also for the concrete design add-ons. And he works also in the customer support team. Okay, I say something how you can ask questions, at least for the attendees who participate the first time. At first, I switch off my webcam that you can see the full screen. Yeah, just press the button with the question mark, then enter your question in that field, press send, and I will receive your questions and I will answer you. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, that's for the moment all from my side. I hand over to Richard. Richard, you can start.
Okay, first, thanks Andreas for the introduction. And yeah, hello from my side. My name is Richard Hase, and I will lead you through today's webinar about the building model. And yeah, we can start. I will present first my content, my topic points I will present you. Yeah, the first point are the advantages of 3D modeling using a building model. The second part, a little comparison with positional structural analysis. And at the last point, a little impact of our add-on construction stage analysis, and also the connection to the time-dependent analysis add-on. Okay, then let's start with the webinar. And the first is about advantages of the building model. And here I will show you in RFEM 6 the quick modeling via using DXF background layer. So in the building model, we have the option to modeling from the, let's say, bird view. And there you define the stories first, and then you can modeling very fast. But I will show you in real. And this is only possible really with our building model add-on. And yeah, it saves some time. Also, there are created visibilities, and they will created automatic the stories. So you don't need to create on manual way object selections or views. There's an automatic which help you. And okay. Then we have two types of slabs, let's say, rigid and a semi-rigid slab system. And these both types have the additional option that you can see the load distribution. So when you have a surface load, you can switch and see which, for example, which wall, which column get which forces, and it's for a better control, a good way. Also, we have the option to create shear walls and deep beams. So yes, you can do this on manual way, but therefore you must create additional members and select them over result beam. and result sections. But here in the building model, this is simplified, and you get additional result informations. I will show you this for a shear wall. And yeah, so it's a simplified thing here, but yeah, I will show you later. And I don't forget this deep beams and shear walls. We also have added some checks with the concrete add-on. So this additional concrete add-ons really only possible when you activate building model and the concrete add-on. Okay, then another good thing from the building model is that we can separate the types of calculations when we use the rigid or the semi-rigid slab types. So when we use this one of these both types, we have the option to see every story in a 2D slab calculation, a 3D wall calculation, and a sum of these 2D and 3D. And so it's better for analyze and comes close to this structural traditional analysis type. So, but I will compare this in RFM 6 later. Okay, at least we have a lot of additional informations which are very informative and for dynamic and seismic checks. For example, here we see the interstory drifts, or also the center of mass and rigidity. But I will come to that later. Okay, then let's switch to the next chapter. Here a little overview about a comparison with positional structural analysis. The pros of the positional structural analysis is, of course, you can modeling this very fast, and also do the design checks, and you only have 2 degrees of freedom in this 2D calculation. So you must consider so much effects and so on. It's very simple, and you can check it very easily. The cons are when you design a slab or let's say a story, you calculate this, then you must make a load transfer from story to let's say to the walls, to the columns, and from there again to the slab. So you must all time transfer new and new again until you are on the ground floor. And yeah, there you can make failure very easily when you forgot some loads. And yeah, so we also have the option to do this with RFM 6. I will also show you that we are possible to do this, but yeah, that's that's the thing that you don't should forget something. But yeah, we also have this story, and I will show you. Okay, another con is that in this 2D calculation are neglecting 3D effects, and for example some forces, let's say torsional moments, and you also need separate additional considerations or additional checks which are for the whole building. And yeah, now to the building model. How I say before, we have this 2D and 3D calculations and can check this for their own. And yeah, how I say, this load transfer is not necessary because we have one 3D model, and when we change something in the 3D model, all load transfer is automatically actualized, and yeah, you can do so much failure with that. Also, which is a good point, we have an overview of forces and results by story. That's also a new point, which only is possible with the building model add-on. So this analyze by story. So you have directly an overview over all results from deformation of forces, and yeah, okay. So this means about because we have this additional results, and we don't need separate additional checks or something. We have our 3D model, and also the 3D forces are considered. So yeah, it's more simply to have an overview about the whole building and their design checks. Okay, now about the impact of our construction stages analysis. It's more nice to know. I will only want to show you the options you have with our add-on. And yeah, here you are possible to consider construction stages. So I will show you, for example, here that first the walls and the columns. Then let's say after 30 days, we make our slab from ground floor. 30 days later, the first story, and again. So you have in connection with the time-dependent analysis, the option to also to consider the time, and that's very great for because I'm of the concrete team. That's important. What I think about first, the material parameter, for example, for the creep and shrinkage. So you see, after 30 days, it's a complete different creep coefficient in comparison to 120 or 150 days. So you will have influence only from this material parameters, and yeah, we can consider this when we use the construction stages and the time-dependent analysis. But I will also show you this later in Offerm 6. Another option you have with these construction stages is when you have, for example, temporary loads, which are only for a time or for a construction stage, and these loads are away at the end of the building, so you can consider these loads. Or let's say when you have an additional column here, which have effects on the reinforcement, for example, you can consider this also and add, for example, yeah, this column in one construction stage and delete it in the next. So you have the option with this add-on to analyze different models, let's say, in one calculation. Okay, yeah, that should be with my overview what I want to show you today. And now let's switch to Offerm 6. Therefore, I will create a new model. and let's call it building model in 3D type of model, of course. And here are the add-ons we need. At the end, I will show you the construction stage analysis and the time-dependent analysis. But for the first step, I only activate the building model add-on and our concrete design. Here in the standards, I choose today a German example. So let's choose national annexes here. And what I also want to show you is we have load wizards for wind and for snow. And a nice connection we have, I want to show over the model parameters. So if you know, we have our GeoZoom tool where you can see the forces from seismic, from snow, or from wind, and we have a connection in RFM6 directly when you click on this button. In the background, open our GeoZoom tool. Here you see our informations about snow, wind, and seismic. So let's take our Dlubal office in Leipzig and say OK. And so we see here the characteristics values of the snow load and also of the wind loads. And when we click OK, RFM6 imported these informations from the GeoZone tool. And when we now click OK, RFM has the informations, and when we click later to the load wizards, RFM have directly the informations, and you don't need to choose the category or the wind zones and so on. But yeah, I will show you later. Okay, then let's go to the materials. I have chosen concrete C30 and reinforced steel B500. And of course, I want to show you the quick modeling. Therefore, we need under the guide objects our background layer. Okay. Okay, here we have our background layer. And yeah, first let's switch to the building model. And here we can create our building stories. And let's say we want to have a 3-meter height and want to have 3 stories over the ground floor. And we want to choose here our floor type rigid. And when we choose semi-rigid or rigid floor diaphragms, we have the option to choose here for all nodal and line supports. We can choose the supporting type, which you can analog design in a 2D calculation. So let's say we want to have for the upper floors hinge to hinge, and also here hinge to hinge, and in the ground floor we have a rigid hinge and also a rigid hinge. Okay, then we have created our stories. And yeah, then let's begin with the modeling. First, okay, maybe we delete this and say, okay, I need a new section. And we see here we have circular columns. So I choose this column. Okay, let's say 200 is the default setting. And now we want to measure the informations directly from the DXF background layer. And can say, okay, from here to here. And it's switched to 500 millimeter diameter. And say, okay. Then we also have our walls. Therefore, we do the same, a new thickness, and say, okay, that I only changed is that you see that it works, 300 millimeter. And let's say it's a default setting, and I measure now the informations from the DXF file, and we have our 200 millimeter for our walls, and we need a new thickness. And yeah, I show you for the slabs, and it's 24 centimeter. Of course, you don't read this information of this 2D background layer, so I take this information and then it's fine. Okay, then we have created our section and our thicknesses, and now I want to change for the input our rendering. Therefore, you go to the model, solid model, surfaces, and here we have the option filled inclusive thickness. So that's very good for control. You will see what I mean in a few seconds, but let's first start with the columns. So yeah, this button is really limited for the building model add-on, and this button gives you the option to modeling via the bird eye view. So let's start with our columns. Okay, yeah, we choose our measured section, and here we can select the building stories, and let's say, okay, we have this column in all building stories. Apply, and oh, I do a mistake, sorry. Again, I click too fast. Okay, and yeah, so we have these columns, and go here, and you see directly this big bubble. It's the sum of the masses per story. So when we click here to another point for the columns, you see, okay, it's growing and moving more in the middle. So, and let's do this for the others too. And our columns are ready. So now the same game for our walls. Our 20 centimeter. Okay. Maybe we switch back to the bird eye view. And yeah, wall 20 centimeter. And now you see here our rendering option. There you have a direct control option if the thickness fit to the background layer, and you see, okay, fit. The default setting is only filled, and therefore you have this 2D visualization and here we have the real thickness, and yeah, I prefer this for controlling. And yeah, okay, let's continue with the other walls and our last walls here. Okay, so, and okay, one thing is missing, that's are the slabs. And let's choose here the rectangular floor. Therefore, we need the other thickness, 24 centimeter. And of course, yeah, all stories is activated. And good. Now we see here these red lines. It's the special thing of our slab type rigid, because for this rigid slabs, there is a moment. We have here also special objects, yeah, rigid links, and this rigid links connected the edges of every slab to the center of mass per story. So this is a good point for dynamic analysis, because it's let's say simplified the masses to one point, and it's then more clear for dynamic and seismic analysis, and this reduces also the calculation time and the eigenvalues. And yeah, this really nice feature for dynamic analysis. Okay, so we also can deactivate it here. One moment, it's, yeah, special objects. Okay. And now let's continue with the supports. Let's say we have here our fixed nodal supports. Okay. And also the line supports, let's say it's also rigid. Choose here, here, and here. Okay. Then let's go to the loads. Therefore, we must create some load cases. Let's say here self-weight, okay, or dead loads. And here we need some live loads. And yeah, the snow and the wind load cases I will show you through the promised load wizards. So let's say firstly okay here, and go now to the load cases and create some surface loads. Really simplify, but it should fit. Okay, let's say we have here 2 kilonewton per square meter, and we can say apply and next. So, and switch to our live load case, and here we want to have 3 kilonewton per square meter. Okay, and let's finish this. So we also have the option to control this very fast, but it looks good. So then let's switch to the load wizards. We have here the option to activate such load wizard. Relative new, let's say we have also load wizards for the moving loads. Here are our support reactions. I will show you that later, what you can do when you have 2D structural analysis, and so you can, with this command, copy and transfer the loads from story to story, or yeah, what I described before. Okay, but let's go to the snow loads first. We want to create a new load wizard for snow. Must here first pick the roof corner nodes, and let's see, here, and here, and yeah, we have a flat roof type. Go now to the parameters, and now we see what we do in the beginning. The definition type is changed to map and parameters, to this German location, and you see here it's automatic see which load zone with height, which height, and the characteristic snow loads and other coefficients. And yeah, so you this is simplified, and so it's easy to switch here. Okay, then to the load cases. So you see here, okay, I would create a snow case here for you, and you only must click this button, generate load case, and say okay. And very fast, we have now our load case here with our snow loads, and the same works for the wind loads. Here we must, okay, that's the base corner. And here. Okay, the same for the roof corners, for the wind. Okay, so then you see on this picture, we have here our 4 wind directions, and let's say we limited this to wall 1 and 4. And okay, the parameters here is the same. You see our location, the terrain category, altitudes and heights, and load zone. It's automatically transferred from our map. And yeah, so we have here again this option to generate automatically our load cases. And yeah, we have here 2 Ks per direction, and say okay, okay, and we can prove it, of course. So we see here our wind loads, here special this load area for the slab, and the same works here for the other wind case. Okay, so our loads are finished, and yeah, I don't want to waste time with calculation, and would switch now to a calculated model, our building model. Here we have results, and let's go to the dead loads and switch to the static analysis. So, oh, I don't have calculated. Okay, yeah, and here we see the first thing which is activated when you have chosen the rigid or the semi-rigid floor type, that it is calculated 3 times, and that's because of we have now here an additional option in the static analysis of building stories. So you can have a look only on the floors, on slabs, and I want to show the, let's say, internal forces, the moments. Switch back to all, and now you see here really only the results per story per slab. When we switch to the 3D walls calculation, we have additional our walls, and because these walls are connected during via the slabs, also internal forces can be in the slabs. And yeah, this last option, walls and floors, is a, let's say, sum of these twos. And yeah, here we have our combined results. But what I want to show you before is our load distribution for the case of the dead load. Oh, and I forget here our visibilities, which are automatically generated, sorry. And now we have the option, or in normal case, you must define this by yourself, and the building model add-on created automatically per story, so you can easily switch and have really every story fasten generated view for that. Okay, but let's go to the third floor, and yeah, here we have our surface load, and we have now the option to see how is the load distribution. Therefore, we right click on the surface and have here this button loads from distribution surface, and now you see how the surface loads is distributed to the walls and the columns. And when you double click on the slab, you see here our stiffness type, floor slab rigid, and we also have here a load transfer menu. Default setting is the FEA type, but you also can say, okay, it should only in the local axis X or Y stripes, or X and Y stripes, if you want to do that in this way. Okay, but let's switch back. Okay. Another thing, what I also mentioned on my presentation before, is that we have in the building model, yeah, this is the building stories you already see, and now we have also the option to define shear walls in deep beams. And for the shear walls, I do it here before. So when we click here, we have this one wall, and it is easily to define. You only must select surfaces or surface cells, or even a member is also possible. And yeah, in the background, we can see here we have our columns, and this purple, the shear walls, are what is generated in the background. And yeah, you can see also here it's a result beam, let's say, which integrated automatically surface, which are, or surface cells members, which are chosen before. And finally here our member sets. So you see, you also can do this on manual way, but the building model add-on simplified the steps. And another good point is when we switch or go to the static analysis, we have here a new chapter result by stories, and can really see, okay, which methods come from which story. Can hear story actions, horizontal forces, for example here, or interstory drift of deformation. And also have here, because we define now our shear wall here, we have a new chapter, member forces in shear walls. So you also see here the axial forces, or the shear forces, moments separated for every story. And yeah, that's the feature which only can the building model. So you, of course, you can create it via a result beam, but this results by stories you would have without the building model add-on. Okay, then maybe let's switch also to the concrete design, to the configurations. And because these walls and deep beam shear walls and deep beams are result beams, so we have under the concrete configurations and the chapter members really or special additional checks, which are only possible when you use the building model add-on. And yes, and also for a better overview, the concrete design, when we check here, we have also additional design ratios or reinforcement calculations for shear walls and deep beams here. So yeah, again, when you don't use the building model, all these ratios would to find on the members, and so you have an extra chapter for that. It's yeah, simplified the work and given better overview about the results. Okay, then let's compare to let's say traditional way to analyze slabs. We want to have a look on the third story, and I will show you that we have really exact the same results. And therefore I want to create the windows next to each other, and when that's not the was also the wrong. Okay, now we have selected our both. I want to show you again window. And go here, select only the third floor, and okay. Now you see the 2D model, which is choosing also here type of model, 2D plate, and let's compare here the required reinforcement. Let's go here, and with our building model, you see we have exactly the same results. And here, let's do it again. Okay, and the last one. Yeah, so you see it's with the building model, it's possible to have a traditional structure analysis calculation of 2D, but integrated in a 3D model. And yeah, you get the same results here. And yeah, that was what I want to show you. So yeah, okay, maybe we go, I hope this was the right model. Yeah, to the ground floor. Because I also want to show you the option with the load transfer. And show you that it works on the same way with the 3D model. So yeah, I have created every story, an extra model for every story. So and here my last step was to load transfer from the first story the forces to my ground floor slab. And here you see this connected model. The thing that it works, you must create in our Dlubal Center connection that all models are in the same folder, and yeah, then you have the option to connect these models. And when we switch to the object chapter, you're also free to use it by manual. There you can say, okay, for example, I only want to transfer from only single nodal supports or single line supports to this and this node or line. Or the faster way would be free loads, and they're created from the support reactions, free loads on our actual model. Yeah, then to the loading, you also have the option here to say, okay, I want to choose it manual. So you can transfer from load cases or also from load combinations to our actual load case or load combination, and can choose here also the type of forces which should transferred. So I only choose here the Z direction, say okay, and yeah, only for comparison of the dead load, you see here again in this purple color the loads which come from the first floor slab, and yeah, can control it here, also the forces, and yeah, and this models are also connected. For example, when I change something in the second floor, these load transfers are connected with each other because they are in the Dlubal Center folders, and then it's an automatic recognize that this change also results. And if you don't want this, you can also say, okay, that's finally good enough. You can separate here the connection, and then yeah, it's fixed. Okay, but the thing I want to show you are the sum of loads, and we have here our 7.2 meganewton, and when we switch back to the building model, so 7.2, dead load result by stories. We have also here 7.2 here in ton, but we also can do this when we cancel this over the static analysis. Here we have vertical result lines, also a feature only from building model. You can say forces and FZ, and you see also here the forces per story, and finally also here at our 7.2 meganewton. So the masses are identically when I choose it in 2D and 3D. Okay. Then let's maybe we can deactivate it again to the story actions. So I mentioned also that it's have pros when you use dynamic analysis or seismic analysis. So you have here, okay, for dead load it's a little small, but the forces in global X and Y, and these forces you can compare, for example, for the seismic forces, and can think about it if the seismic forces are governing, and also with the interstory drifts you can do serviceabilities checks and say, okay, this deformation per story is too high, or it's okay. So and also, but I don't want to blow up here this model. We get also, but I only want to say to you, when you would have activated this response spectrum analysis, you would also have this result by stories chapter for the response spectrum, and there is also a value which show you, okay, is it allowed to calculate to theory of first order, or you must switch to second order, or let's say so first order is geometrically linear, or the second order theory. So okay, okay, and about the rigid the rigid links, I tell you before that it have a good effect for the seismic. Okay, we also have two additional story types. I want to say something about it too. Here are rigid and semi-rigid. Then we have also without stiffness, and that's really only a slab without stiffness, and which are only load transfer, and in some cases this could be usable. And we also have here this non-original stiffness, and when I choose this, then I don't have these 2D and 3D calculation types. This is how when I model a normal 3D model, so I must create the hinges and conditions on manual way. But what I have when I choose this is also this additional informations and result types, result by stories, and so this is for every type usable. And okay, so then let's have a look on one combination. I choose the 19 and compare here something. Or wait, let's go first to the third story And of course, when I have a 2D model, an X, we don't have axial forces in the slab, because we have this 2D model. And when we switch now to the building model 19, we see various surfaces, and we want to see all about extreme values. We see, okay, we have nearly this 0 normal forces, so it's very close to the 2D calculation. And now I want to open a model with the construction stages. So when you really, what I show you on at the beginning, when I really consider the stages, and we go to this third slab, you see, okay, we also have here some axial forces in the slab, so this could have influence on the results. So only that you know, okay, why there is a difference between this 2D and 3D. Yeah, it could be because of these axial forces in the slab. Okay, but that should be with the building model. Now I'm in my construction stages model, and yeah, then I want to show you here short some things about it. Maybe we go in this, and yeah, with the construction stage, we also have here an automatically visibility, and can see, okay, which construction stages I define here. Yeah, I forget to rename it. So it's the ground floor. Then in the second step, the slab is editing. Then the next floor, and so on. So, and this construction stages we also consider for the load cases. So I have here an additional construction stage menu, and there we can say, okay, at our first we only have permanent loads, and so I can switch the load cases for every construction stage, or even delete. Here, for example, I have, say, okay, our snow and wind really only should be there in the last construction stage. And these construction stages are also considered in the generating of the load combinations. So you see here, these CS2 are the construction stages. And so you have really calculations for every construction stage. And yeah, it's the most realistic calculation which is possible, I would say. And also I tell you about the time-dependent analysis and the creep and shrinkage effects. So therefore you must activate this time-dependent analysis, and in the construction stages we can then define the duration, start and end time again for every construction stage. And so this material parameter of here, for example, for the concrete, can be considered over a time. And yeah, that's, I find it's a very nice feature. Okay. Yeah, that should be with my webinar. I hope I can give you some new informations. And if you have questions, please write us an email, or if questions are open, we will fix answer to that. And yeah, I hope you enjoyed this webinar and want to say thank you from my side. And yeah, see you. And so I would give back to my colleague Andreas.
Thank you, Richard, for your presentation. I have an additional hint for you. You can book our online courses. For example, the AFM6 course. It's a course for beginners. Then the Eurocode 2 course for the reinforced concrete design. The Eurocode 3 course for the steel design. The Eurocode 5 course for the timber design. And the Eurocode 8 course for the earthquake design. For more information, just scan the QR codes in the middle or click at the buttons at the bottom here. In the next days, or maybe today, you will get an email with a link to the event page where you can find the recording and the slides and models. The email contains your attendee certificate as well. In the next days or today, you will get it. Okay, that should be also all from my side. I thank you for your attention. Thank you, Richard, for your presentation. I hope we meet each other in a future webinar. Bye-bye. Thank you.